We will now start talking about right triangle trigonometry. First thing I want to do is, before I go and define my trig functions, I want to draw a picture, and we're going to relate the definitions back to that picture. I'll draw vertical and horizontal axes. I will plot a point at the origin and start an initial side along the positive x-axis. I will rotate that side, and for sake of example, I'm going to end the terminal side here in the first quadrant. And I'll have my theta value on the inside. Now from this, what I will do is I will form a right angle by drawing a line up from the initial side to the terminal side and forming the right angle in that corner. From here, I will now go and I will label certain distances based off of this drawing. Okay, the distance from the origin out to the right angle we're going to call x. The distance from the right angle up to the terminal side, we're going to call that y. And then the distance from the original point up to this particular point, we will call r. Okay, you're familiar with this labeling. Pythagorean theorem identifies that if you have a right triangle, then the sides compare as x squared plus y squared is equal to r squared. And we'll go ahead and we'll write that down here, because we will need that for later on. So Pythagorean theorem states that for a right triangle, the sides compare as x squared plus y squared equals r squared. Now, from this particular point, I will go and I will define 6 trig functions off of these 3 sides, x, y, and r. Okay, so trig function definitions. Okay, number 1, we will define the function that we call sine. We denote this in function notation. We say sine of our angle theta is defined as the ratio of y divided by r. Next, we have cosine. Once again, we'll use function notation. Cosine of the angle theta equals the ratio of x over r. Okay, the next one is tangent. Tangent, using function notation, is tangent of theta equals the ratio of y over x. Now, these are what we call the 3 basic trig definitions. There are 3 others, and the 3 others are actually reciprocals of the ones that I already have written. We have cotangent. Cotangent of theta equals the reciprocal of tangent, x over y. We have what we call cosecant. We have secant next. Secant of theta is the reciprocal of cosine, r over x. And then finally, we have cosecant. Cosecant is the reciprocal of sine, r over y. And so there are my 6 trig function definitions. I call these 3 reciprocals of tan, cosine, and sine. Okay, in that particular order. So if I know 3 of them, I know the other 3 for free. Now from here, what I want to do is I also want to go and I want to define the first 3 using different terminology. when we go and we're looking at an angle, you'll see up here, here's my angle theta, then relative to where that angle is, we can also denote names for the sides. The side that's right next to my angle, that's not the hypotenuse, is called the side that's adjacent. Now do be careful that you don't get the idea that x is always adjacent. In other words, if you orient the triangle in this particular way, then yes, x will always be adjacent. But a lot of times our triangles are oriented not on an xy axis, and so it's important to know that the x is not necessarily the adjacent if you have something oriented in a different way. The vertical distance here that's opposite of your angle is the opposite. And then, of course, r is known as your hypotenuse. Now, that being the case, for the three basic trig definitions, we have another way to define these using these words. Sine of theta, we say, is opposite over hypotenuse. Cosine, we say, is adjacent over hypotenuse. And then tangent is opposite over adjacent. It's just three different ways to say the same thing for this particular definition. Now let me do an example and let me show you how these definitions would be used. Okay, for the following triangle, find the values for each trig function. And purposefully, for this example, I'm going to draw a triangle that is not oriented originally on the xy axis. So here's a triangle. It must be a right triangle for you to use the trig definitions. Okay, I'm going to label the side down here as 1. I'm going to label the side up here as 6. And then they're going to have to denote for you which angle that you are looking at. Let's say that they want the trig functions for the angle in the bottom right, the way I have this oriented. Now, you have two choices as far as how to go and to draw this picture. You can leave the picture as they have it drawn, and you can use the opposite over hypotenuse, opposite over adjacent. You can use those other definitions. Or what I like to do is I like to reorient my triangle, and I like to reorient it on an xy axis. What you want to do if you want to reorient is you always want to make sure that your theta is right next to the origin. So in other words, I would put one side over here, the right angle up, and then this side over here, and make sure that my theta is right in here. Now the only thing I have to be careful about when I do this is making sure that I have everything oriented correctly. 6 is obviously the hypotenuse, so there's not a problem there. Okay, and then do you agree that 1 is the side that's next to the angle? In other words, the 1 is adjacent to the angle theta, and so that 1 would need to go down here. Now, in this case, this to me is just easier to visualize because I can say that my x is equal to 1 and my r is equal to 6, and then I need to figure out what y is. Let's first go and figure out what y is. Use your Pythagorean theorem. So in other words, x squared plus y squared is equal to r squared. As long as you are given two of the three sides, you can always find that third side by using Pythagorean theorem, as long as you have a triangle, which is a right angle. On here, we know that x is 1. We do not know y. We know that r is 6. Okay, 1 squared is just 1. 6 squared is 36. If I subtract over the 1, I'll have y squared equals 35. And then at this point, I would need to take the square root of both sides to find y. Now technically, when you take the square root of both sides, you should put a plus and a minus in front of your square root. Think about a triangle drawn in quadrant 2. A triangle drawn in quadrant 2 would have a negative x value, a positive y value, and a positive r value. So depending on which quadrant you're in, the values of your x's and your y's may change in sign dependent on your quadrant. On this, for this particular set of material, always assume you're in quadrant 1, and so that being the case, you're always going to choose the positive value. So y equals the square root of 35. Now from here, I will go to the side and I will write down the values of each of my 6 trig functions. Sine of theta, I know that that's y over r. The y value I found out was square root of 35 from down below. And so I will have the square root of 35 divided by 6. Now, one of the things from algebra is if you have a fraction and you have a root in the denominator of the fraction, it's not simplified. This particular problem, you see the root on the top, you see a constant in the bottom, that's fine. Cosine of theta. Okay, cosine of theta is equal to the ratio x over r. X is 1, r is 6, so we have 1/6. Tangent of theta. Tangent of theta is equal to y over x. The y value was the square root of 35. The x value was 1. You need to reduce that to just 35. I'm sorry, the root of 35. All right, and then from here, what you have is you have the reciprocal functions. So we would have cotangent. Cotangent is the reciprocal of tangent. And so whatever value you got for tangent, take the reciprocal of it. So it would be 1 over the square root of 35. Now we have run into a case where this problem needs to be rationalized. You need to get rid of the root in the denominator. Whatever the root in the denominator is, multiply both the top and the bottom by that same root. And so this would reduce to the square root of 35 on the top, and then the square root of 35 times the square root of 35 is just 35. The root goes away. Okay, now we need to do secant. Secant of theta. Secant is the reciprocal of cosine. Cosine was 1 over 6, so this will be 6 over 1, or just 6. And then finally, cosecant of theta. Cosecant is the reciprocal of sine. Sine was square root of 35 over 6, and so this will be 6 over the square root of 35. That needs to be rationalized. Multiply by the square root of 35 by the square root of 35. On the top, you can't combine those two numbers, so it's just going to be 6 square roots of 35, and then on the bottom, the root goes away, and you're left with 35. And so there are your 6 trig function values. Like I said earlier, once you know 3 of them, you know the other 3 for free. This concludes the example on trig function definitions.